All right. Hi Wanderers! We're back with another video on how to identify minerals and crystals. In this video we're going to talk about luster. I think that luster is a really fun topic in geology. It's extremely subjective, which I think can be a little frustrating for people who are science-minded, which is perhaps why I love it so much, because it causes rumblings sometimes, I feel like. There are like standards for different lusters of different minerals. Like if you look up, like vitreous luster, there'll be certain examples that kind of are standard that come to mind. But yeah, we'll discuss what luster is, the official definition of it, and how you can use that to identify your minerals. Luster, in essence, it describes the way that light interacts with a mineral or material's surface. And the subtexts of luster, there's different little categories that go under it, kind of refers to the quality and the intensity that the light is reflected onto the surface. So, for example, something that's just kind of like a dusty rock is probably not going to be in the same category as like a super brilliant diamond or a really clear aquamarine crystal. So we're going to discuss that. The first thing with luster is it opaque or is it transparent? That's essentially just referring to if light can pass through it, which some of us might be familiar with, and if not, that's okay too. So we're going to jump right into the different sorts of lusters. The first two that we're going to cover is metallic and submetallic. Those are how you're going to identify like the transition metals on the periodic table. So like gold, silver, copper. Those are generally going to be a metallic lustered mineral. Things like iron can be submetallic or even dull to earthy. So some metals, it's a spectrum. It really just kind of depends on the specimen that you have, with a couple of different examples that we're going to look at here, but nonetheless, there are standardized little packets of information for it. So the metallic luster are going to be pieces like this. Things that are metallic, the light is going to bounce off the surface and it's just going to resemble metal. That's pretty much what a metallic luster means. And I'm going to pull up another couple of examples here. So this is a really gorgeous piece of pyrite. This is a very, very metallic, shiny piece of pyrite. And then this is kind of a mixture of things. It's an interesting little guy. The blackish metal bits are going to be the sphalerite, and then I think this is chalcopyrite and then pyrite. So very, very metallic, very shiny. The light is refracting off the surface. It's opaque. It resembles metal. The next is submetallic, which is similar, but it's just not quite as shiny. So this is an example that I was able to find for submetallic, where you can tell that it's metal-ish, but it's not a metal that, you'll write home about in terms of shininess and refractivity. It resembles metal, but it refracts the light poorly, it's not shiny. So here are our examples together of metallic and submetallic lustered minerals. Very pretty. Let's try to get that to focus. Okay. So the next bit that we'll cover is non-metallic luster. And non-metallic luster essentially just means anything that isn't metallic or submetallic. It's essentially all the lusters that are anything else. So there are a couple subcategories that I'm going to talk about. You might be able to find extra ones that aren't on this list, or ones that have use different words than this list, but this is a pretty standard list that I'm going to present, and anything I should add, definitely let me know, and I'd love to get back to it. So we'll get into the non-metallic lustered minerals. which are as shown. There's a couple of different types, and we'll go through these individually, but I just wanted you guys to see the different examples all together and just how different they look when you're approaching them, essentially. So we'll get started with an earthy or dull lustered rock. And these are rocks that reflect light poorly, they're not shiny, and another kind of sub-modifier of these is they're generally aggregates of tiny grains. So I believe what that goes for is it encompasses just like sedimentary rocks, or more so rocks than minerals. Most of the minerals that you find are not going to have a dull or earthy luster. Some do, but here is an example of a dull or earthy mineral rock. This is an example of wonderstone. As you can see, it is an aggregate of tiny grains. It's like a very sandstony rock. And it does not refract light at all. It's very flat. It's very not shiny. The other example I had for it was this andradite garnet, but it doesn't really, it's not very shiny. It's also kind of dull, but I don't think it actually is a good one for that. So never mind. The next one we'll look at is resinous luster. Resinous luster is not one that you'll encounter in the field a lot, in my experience. It's essentially just a mineral with a sheen that resembles resin. Most of the time, amber is going to be the example for this one. I found this big chunky amber necklace with a lot of good little pieces on it. Amber is a really interesting mineral in that it's not really, well, I suppose it's a mineral. It's a fossil though, technically. It's formed from fossilized tree sap. So it is kind of like technically a resinous material, but yes, anyway, yeah, that'll be the resinous luster example that we have. The next one we'll go over is pearly luster. That is minerals that have an iridescent, opalescent, or like a pearly sort of a sheen to them. Obviously, I could have gotten a pearl, because that's going to look pearly, but I wanted to get a little more creative with this one, especially because I just had such a fantastic piece to show you guys for the example of this luster. So our example for the pearly luster is this massive piece of mica. I have rarely seen a sheet of mica this big. It's bigger than my head. So, very cool piece. Anyway, so yeah, you can see that it's a shiny material, but it's shiny in a way that's kind of weird. It's like, it's not like a sparkly shiny. It's just like, it's refracting light in there for sure, but it isn't sparkling it out. Kind of like how a pearl would. Let's go find a pearl, because I suppose I should have just gotten some. Let's see if I can find one quickly. I just saw them somewhere. Maybe I won't show you guys what a pearl looks like. I think a lot of us are reasonably familiar with what pearls look like, but in the interest of pearly luster, I thought I could grab it. I guess not. Embarrassing. Anyway, The next one we'll talk about, hopefully I can find a pearl later. If I find a pearl later, I'll show you, I'll bring it out. The next one that we'll talk about is silky. That's a good one to do next. The silky luster is, it looks like almost fibrous. Fibrous is another luster category. I didn't list it because I felt like it wasn't super necessary. I feel like this list is pretty comprehensive on what you'll realistically run into, but the silky luster is generally identifiable by light reflecting. I can't do my RL words tonight. Light reflecting on aggregates of small grains that are parallel. So that's the key factor for this one. Malachite is a great example of a silky luster. I know that we had this like really cool sheet of malachite. I could only find this bit of it. I'll take this with me. Actually, it's kind of right up on the table. So from the outside, it's not really what I'm trying to demonstrate, but if you look on the inside, I'm going to shine a flashlight on this so that you guys can see what I'm talking about, just to provide a little extra light. But this is a silky luster. This isn't like, oh, true. I just realized that there are more pieces of malachite that are more silky. I just remembered this big chonky one over here. This one's not quite as silky looking. It's kind of like fuzzy, but I think if I shine a flashlight on it, it should give us what we're looking for. Let's see. So here's this big piece of super velvety malachite. And so you can see the silky luster in there. Yes. Malachite is a super radial crystal, so it'll kind of have like a speck in the middle of the different nodes. And then it'll grow around it like a circle. So you can see those parallel fibers and how the light's bouncing off of them in a way that kind of resembles like a silky fabric. So that's a really, really good example of, it's even showing those qualities without the flashlight. That's cool. So that's really a good example of a mineral with a silky luster. We'll do the greasy luster next. It sounds kind of silly, but these are minerals that, as you can presume, look like they have a layer of oil or grease on them. So they're not quite sparkly, but they're not like not shiny. They're just sort of, but they're not dull. They're just sort of greasy looking. I see a lot of treated calcite look like this too, where like acid treated calcite, where it starts to look kind of like soapy. I've also heard this category referred to as soapy as opposed to greasy. I kind of prefer soapy because greasy sounds a little yucky, but yeah, calcite is generally considered a vitreous lustered mineral, which we'll get to in a second, but when they're acid treated and it changes the composition of the surface, I find that they can have that soapy or greasy luster as opposed to the vitreous one that it naturally would have. The next one we'll talk about, if you can guess, is vitreous. Vitreous lustered minerals are minerals that refract light in a way that resembles glass, like broken glass in particular. So we'll go down and look at the vitreous minerals. So here's some examples of vitreous minerals. Quartz is a big one. And you can see it's mostly transparent. This is a really, really good example of a vitreous luster where it just looks glassy. And then I've got this really gemmy piece of calcite that I stole from Nate's office. And this one is a very vitreous-y luster. And then there's this one too that I found. It's a zeolite. The large crystals are apophyllite crystals. And that is another example of like a glassy, vitreous luster. The last one that we'll talk about is adamantine or brilliant luster. These are minerals that are dispersive and translucent with high refractive indices. In other words, they're really sparkly. So I have some examples. That's a really official fancy scientific term for sparkly. This is what I would consider to be maybe kind of halfway through glass or vitreous and adamantine. It's really, really, really refractive and sparkly. This is the category that your gem quality barrels will start to get into. So emeralds, aquamarines, even quartzes can have an adamantine look to them. I think the best example are probably diamonds or moissanite because you can see that they're like rainbowy on the inside. Generally, that's a quality that they start to possess once they've been cut and shaped into a gemstone. But where those qualities are kind of brought out more. But a mineral that has an adamantine luster just kind of naturally is zircon. Is it gonna focus? I'll just put it on the bowl. Zircon is an example of a mineral that has an adamantine or a brilliant luster. And this is because it is sparkly, but it's not necessarily glassy like the other vitreous minerals. Vitreous minerals have to be translucent, I believe, but these adamantine or brilliants can be opaque, like these zircons here. Or at least, on the translucent to opaque spectrum. But yeah. So, yes, this has been kind of a comprehensive intro guide to luster and how you can use that to identify certain minerals. When you're out in the fields and you're like rockhounding, or maybe you have, again, like something in your collection, you can't quite remember what it is, luster can really help narrow things down quite a bit. I find it doesn't get as highly specific as the Mohs hardness scale, which we have another video on that you can view if you are interested in how to use the Mohs hardness scale. But luster can really take a large category of minerals and smoosh it down into a smaller category of minerals. So let's say if it has like a metallic or a submetallic luster, it's probably not a sedimentary rock or a mica or a diamond. It's probably gold, silver, pyrite, even iron can be pretty shiny naturally on its own. So to get more highly specific, I would recommend using a process like Mohs hardness scale, because then that can really narrow things down a lot more than that. The luster is a subjective way to look at things where it can kind of be on a spectrum. A lot of the time when you look at like kind of a profile for a mineral on like Mindat or even Wikipedia, which I think is a good source for mineral identification and information, it could say, it's the luster is pearly to vitreous, or it's you know, it can be metallic to submetallic. So there can be a range on what it falls under, but it really can help you rule out large categories of things. And then you can utilize other field tools to get a little more specific. So that's how you use luster to identify different materials. And again, that's like essentially how light interacts with a surface of minerals and and the quality with which it's reflected or refracted onto the surface of the material. So thank you for joining me on this little luster crash course. Please go and see our video on Mohs hardness as well if you're more interested in learning more about geology and how to identify different minerals. And I'll be back in another video to talk about cleavage and fracture and which one is more and less helpful. There is a correct answer. One you want to use, one you don't want to use so much. So I'll gather some materials and I'll be back to tell you guys about cleavage and fracture. Thanks so much.